guys, let's kick this thing off. Welcome and good morning. So it's a really interesting time for blockchain and decentralized technologies. This year has been completely crazy. And I've been involved in crypto since 2017. A good friend of mine told me to buy Ethereum, this strange thing called Ethereum, at $45. And ever since then, I got sucked into this rabbit hole. I've worked to help build communities for different projects. I've advised on some projects as well. And I've always been looking out for, what's an interesting technology that could be the next either big thing or next interesting thing, and stumbled across this project called Nillion. Nillion has a technology that is able to use a decentralized network in a really fascinating way. In a way that if you had seen something like this in 2016, 2017, it could have been Ethereum. It could have been the foundations for a lot of the projects we see now that are quite big. So I reached out to the founders and wanted to find out more. And we were able to get this panel put together at the beautiful Soho house, where for me personally, I wanted to dive more into the technology and to find out more. And I know that stuff like this is not easy to locate, easy to find. And if you do and you find it early, the implications could be pretty big. So really excited to have the founders here. And guys, thanks for taking the time to do this. And thanks for coming out on a Monday morning to be here with us. But why don't we start with introductions? You guys have a pretty interesting history, interesting past. Would love to hear about it, and then we'll go into the technology and the project that you guys have from here.
Should I start?
Yeah, we'll start with you.
Okay. My name's Andrew. I have been involved in the founding team. I started two of the top 100 cryptocurrencies. One's called the Reserve Protocol. I was founding CMO. And the other one is called Hedera Hashgraph. I've been involved in decentralized technology since 2011 when I first bought Bitcoin. And now I am really excited because I've been talking to Miguel and Rob about sort of different ways in which to use decentralized nodes, which don't perhaps relate to consensus or transactions, but to relate to something deeper. It's a new paradigm in thinking for me. And from my first startup, which was Hedera Hashgraph, which was a different way to achieve consensus, to my second, which was the Reserve Protocol, which was an algorithmic way to achieve currency stability. Both of those are worth several $1 billion now, and this one here, I think, just looks at both decentralization and data specifically in a different way, and has a very, very wide-reaching implications. So I'm excited. I'm as excited as I was when I found those technologies about this one, and yeah, that's just a little bit about me.
My name is Alex Page. I started out in the finance space for several years. I worked for Goldman Sachs in their American Special Situations group, and also consulted on a bunch of bankruptcies that happened after the financial crisis in 2008. After that, I started my first B2C company, which was taking advantage of Amazon's rise. We were selling products in the US and in the European Union as Amazon grew into the behemoth that it is today. In 2017, I started investing in cryptocurrency, mostly because Andrew started getting really interested in it, and have been in that space ever since. In 2019 is when I really started looking around at some of the kind of the new generation of projects that were coming. After, when in 2019 and in the run up, we saw a lot of really new disruptive technologies that were coming forward. And Andrew connected with Rob and Miguel and came to me and was like, you've got to take a look at this technology. So I started diving into it with him. We actually went to Brussels for 3 days and sat down with Rob and Miguel in a hotel room and talked about this technology nonstop, asking all the questions, the good questions, the stupid questions, and everything in between to really dive into the innovation that they had come up with. And after leaving that room, I knew that we had something that was phenomenal and could be a massive game changer in the space. And so decided to get involved with Nillion and help bring this whole thing to market.
Hello everyone, my name is Miguel De Vega. I started my career working for Siemens, which does more than just washing machines. It turns out that it's the second largest IT company in the world. So I moved to Munich, which is their headquarters, to work at a special task force, essentially solving mathematical problems coming from all the different business units. So it was really interesting because I got to not only solve problems about technology directly, like telecommunications, but also about electric grids, so optimization, or even cities, like planning the traffic on a city. I love maths, so I moved to Belgium, where I did my PhD on maths. And it was essentially about working or describing how the backbone of the internet traffic looks like. And it turns out to be multifractal, which is something cool because fractals are, things that describe nature made stuff like leaves in a tree or branches in a tree. And it's interesting to know that something that comes from humans, such as internet traffic, is actually a fractal as well. So I did the maths there. It was really intensive. During, I think, the course of 3 years, I wrote 27 patents. All of them were granted. And I also was working for Siemens continuously and then also for Nokia. I then switched over to software development in the second decade of my career, essentially working at high scalable startups, still working with maths, a lot of data science, a lot of crypto, a lot of programming language theory. And in 2017, I joined Sedicii as the CTO. Sedicii is Rob's company, so I think it's a good moment.
Our company.
Our company, okay. Good segue into you, Rob.
Good morning, everybody. I feel distinctly inadequate on this panel sitting beside all these guys. I'm an engineer. At least I was an engineer once upon a time. I spent the first 20 years of my life in Japan. Went there, I was fascinated by the culture, just wanted to see how the Japanese did things, and learned a lot. Not just about engineering and technology, but about people and how things work and how communication works and so on. Fascinating place. Took a lot of what I learned there, came back to live in Ireland, where I'm based now, and started a company there, which over the years we listed it on the stock exchange in Australia, of all places. Some people would say, why Australia? Because it was the only place that we could go at the time that had an interest in what we were doing. Started Sedicii, and it was actually here in London that I met Miguel for the first time. I was a one-man band, and we met in Google campus, half an hour away from here. Miguel had his own company, and between beer and pizza and a few other things, we just got to be good friends. And over the years, as Sedicii grew, the context for everything that we were doing was all about privacy. I knew privacy was going to be a big deal when I started back in 2013, and there were no good technology solutions that addressed it, and still there kind of aren't. And we'd been sort of communicating over the years. In 2017, I sort of leaned on him a little bit and said, come and join us, and let's go do this. So he said yes, and it was actually then a bit of serendipitous intervention maybe that I met Andrew at the end of 2017. And all of these things started to join. We had a technology, we had a team, we had somebody who had some really clever ideas around trying to bring all this stuff together. And it was the sort of emergence of crypto and the need for privacy in that space that all of these things started to germinate and create this seed for something that was going to grow into something much bigger. And then, earlier this year, we've been working on two technologies, zero-knowledge proofs, which everybody who's aware of activity in the blockchain world would know about, and another one called secure multi-party computation, where, again, we're thinking about privacy, how to enable collaborations between organizations in a way where I don't have to share stuff, but I can still communicate stuff in a way that I can keep my privacy, I can keep my confidentiality. And Miguel has come up with some really cool stuff. And maybe this is probably a good time for you to dive into what it is we've created.
I think it's also worth noting, in 2017, when I was introduced to Rob and Miguel via a PhD of mathematics in NYU, and I assessed the technology at that point in time, but it wasn't what we call Turing complete. It didn't have, it was in the nascent stages of development, and it was only in 2021 when we've been circling each other, talking, where I thought, well, a new development occurred that was, I think, just sort of finalized and patented the other day, that really changed the game. And that's actually when I brought Alex in, and yeah.
I mean, it really is. It's the technology that, I mean, I heard about it from talking to one of you guys, and I was blown away, right? And so I think it'd be really interesting to have a conversation about that. But then for the guys in the audience, anyone that's watching, you know, if you're hearing this for the first time, it might sound fascinating. It might just sound almost magical. And so, you know, we want to make this pretty proactive. And so if there's any questions that are kind of coming up, feel free to just either jot them down or save them, and then we'll open up questions to these guys. It's pretty rare to have you guys all in one place. So I think the fact that you guys are here it makes a pretty good opportunity. But so help me understand this. So from my understanding, traditional blockchains, they use consensus, right? And so you have a decentralized architecture of nodes. They all come to agreement about something, and then they all come together and they all say, you know, if I think the answer is 5 and we all think the answer is 5, and let's say 51% of us think it's 5, then we've reached consensus and then we can update the network. But Miguel, from my understanding, you have actually found a way to use a decentralized architecture of nodes in a different way that blockchains have been using it, that actually have some pretty big implications for privacy and security. Can you kind of talk about what that's about?
Yes. So the problem that blockchains solve is that of reaching consensus. So imagine you guys are a blockchain, you're different nodes in a blockchain, and the problem is how can you guys agree on the state of a piece of information, like a ledger containing transactions, given the fact that some of you may be bad actors. So you may have a hidden agenda, and maybe trying to convince the others that your version of that ledger is the right one. So within that context, blockchains run something called consensus mechanism, which is a way for you guys to exchange messages and reach that consensus. Now, the thing with blockchains is that each one of you has to have a full copy of the ledger locally. So it doesn't work if I have to store sensitive information on the blockchain. For instance, if I want to store my private key on a blockchain, I would have to send my private key to each one of you. And that private key would maybe control all my digital assets, so it would be really a bad idea. It's something you cannot do with current blockchains because they are not privacy preserving. So SMPC, which is secure multi-party computation, is kind of an alternative way to decentralization. It achieves the same purpose, which is you guys running SMPC can reach consensus, but it treats information in a completely different way. In the example of the private key, what happens is that I take my private key and I run it through a shredder machine. Like I get pieces of it, and we call them particles. And so I give a different particle to each one of you. But the particles are completely hiding the information. So it's impossible for you guys to go from the particle back to the secret, to the private key. And that's even better than encryption. It's a mathematical result that says that it's completely impossible for you to go from your piece of information to the secret. So now we have this situation where you have sort of my private key in this collaborative scenario. And of course I can reconstruct it. So if you send me back the shares or the particles, I can reconstruct my private key. That's okay. But even more interesting, I can do processing with that private key. So I can get you guys sign a transaction for me and send it over to Ethereum. I get the transaction, I run it through the shredder machine, I get again particles from the transaction, I send them over to you. Now each one of you has a particle from the transaction, another particle from the private key. You run the SMPC protocol, and you get another particle which now corresponds to the signed transaction. You send those output particles to me, and I reconstruct the signed transaction. So it's really cool because it's like a way to collaborate in a decentralized environment. So there still can be bad guys amongst you, but in such a way that you are not able to see the information that you are processing.
I think one of the most interesting things about this technology when I found it is, so you have the way I understand it is that you have a base level of information, you transform it into something that is unrecognizable, and then you shred it. Typically speaking, when you encrypt something, you can't process compute on it. You can't run computations on it, especially in a decentralized way. This allows you, this process of encrypting and then shredding allows you to run decentralized compute. Now, what this means to the world, we'll get to probably later on in this talk, but it's still a really interesting way of using these decentralized nodes. If each of you guys were, nodes computers, it's a very weird / interesting way to use this like decentralized system, and it has several implications because you're not actually after consensus. You are after some other. You can use data in a completely different way.
Wait, so help me understand this. So you're saying that if I took, say, my private key or piece of information, and I gave it to you guys, you wouldn't be storing it. Obviously, you wouldn't be storing it on a central server, but you wouldn't even be storing copies of it across a network of nodes. You're saying you actually take the piece of information and you break that piece into then 100 small, quote unquote, particles.
Well, even better, we don't break it. We take it first and then we transform it, so it doesn't resemble what it was once before. That's why the whole system doesn't actually use encryption. It uses something called information theoretic security, which is a level above encryption. It's mathematically provably unhackable. You cannot, and no amount of computing power can break the system. You can just Google it. It's a very well-known sort of information theory. So you have a situation where yes, you are shredding it, but you're actually transforming it first. It's a little bit technical, I get it, but if you're all nodes, then you're all holding pieces of a secret that I've determined where you have no idea what you're holding, but you can compute it. And the only way to bring it back is if you all agree. It's not Byzantine fault tolerant. It's if you all agree to bring it back to me, and then I put it together. But you don't even have to all agree to do that. I can just say to you guys, run a compute on it with you having no idea what you're running a compute on, and then give it to this person over here, give the result to this person over here. So you never actually even have to reveal, you never have to put the secret back together or the piece of information. So it has pretty significant implications for not just encryption and security, but data processing, even transactions, if you think about it. You could reconstruct between all of you a transaction for me, not knowing what you reconstructed, send it off into a blockchain, and that blockchain could process it. Again, we'll get to these.
Yeah, but I mean, you guys mentioned SMPC, and I have looked into secure multi-party computation. That's been around for a while now, right? The ability to take information and to break it off into little pieces, but it sounds like the difference is you guys have found a way to use the information while it's in its pieces. Like I can give you my private key, and then you can sign a transaction for me while it's in 100 different pieces. Is that accurate?
So the real difference and the breakthrough is that with standard SMPC, you can do all this that we've been describing, but it would take too long for you guys to run the computation on the particles that you hold, because you would have to exchange messages between you. And exchanging messages takes time because you're in a network, so you have 100 milliseconds minimum to send every message. It would take too much time. And it is the case that with SMPC, you often find yourself with hours, if not days, of execution time. And that's the reason why you probably haven't heard about SMPC, because it's only found its way towards, in practical applications, in those situations where either delay doesn't matter, you can wait days for the computation, or the computation is so trivial that it can run fast. Now, the breakthrough is that we found a new way to run these computations in secure multi-party computation, which we called NMC. It stands for Nillion Message Compute. Nil Message Compute, which does what it says on the tin, which is that you guys can run now the computation without exchanging messages. And the difference is massive, because it's the difference between running at CPU speeds, which you can do, for example, billions of multiplications per second, to having to send messages for one multiplication, which is the standard SMPC. So it's a billion-fold improvement in terms of performance, and it's what it's really taken this technology into the practical realm.
But that was actually the other thing that I found interesting because Andrew talked about fault tolerance, right? Byzantine fault tolerance. I always thought crypto was interesting because the idea that okay, well, as long as you can stop 1/3 of the network from going bad, then your network is safe. But what happens if more than 1/3 go bad? But from what you guys are saying, this is more than quote unquote Byzantine fault tolerant, in the sense that it's more than that. So how much more secure is it than what you normally see?
So essentially, it's a different way to reach the same result. So in blockchain, there is a 30-plus-year-old theorem that says that in a room like this one with nodes, we can only reach consensus if less than 1/3 of you guys are bad guys. As long as 1/3 or more are bad guys, it's just not possible under the most generic circumstances. So we're saying that it's not possible to send broadcast messages, for example. If you enable for broadcast messages to be sent, then the number goes up to 51%. We haven't changed that, so it's the same conditions, but we have changed the way through which that consensus is reached. Now you don't have to send messages, which is what would take in a standard blockchain, but consensus can be reached instantly and locally in my computer. So when I get the shares or the particles from you guys pertaining maybe to the output of that computation, of the signing of that transaction, I can kind of get consensus instantaneously, locally on my machine without you guys having to exchange any message. And that's the main difference. So we have instant consensus.
I think from a security perspective as well, these individual particles that are distributed across this network, because they are meaningless and because it requires all of the particles together in order to reconstruct a secret, even if you had a malicious actor, the worst outcome that a malicious actor could have on the network is preventing you from accessing something you have the right to access, right? An individual node or even multiple nodes acting in coordination maliciously can't reconstruct the underlying secret. They have to have all of the particles in order to do that. And so when you decentralize this information, when you send these particles to all these various nodes, even if, let's say there's 100 nodes, even if 99 of them are malicious, they still can't reconstruct the secret. The worst that they could do is prevent you from, say, accessing your private key, but they can't actually get the secret themselves and reconstruct it.
Well, wouldn't you, if I was using this, wouldn't you just hold on to one of the pieces then?
That would be a way to secure a piece of information that you are only really interested in reconstructing. So if we're talking about, say, a private key or a secret, where really what you're interested in is keeping that unhackably secure and being able to reconstruct it yourself, you could hold on to one of the particles yourself and secure it however you like inside of encryption, what have you. But when you hold on to that one particle, then you're going to prevent the network from undertaking the computation. So when we're talking about using a private key to sign a transaction while it's in this decentralized form, you wouldn't be able to do that if you held on to one of the particles. But if you're mostly interested in making sure that nobody is ever able to hack into that secret, you could hold one of the particles yourself.
But that was the thing that confused me. So let's say I give you, I don't know, my private key or something that's sensitive, and you break it up into 100 pieces. What if one of the nodes goes offline, or they decide not to compute, or sure, my secret is safe. It sounds like it's very safe, but what if I just can't access my stuff? Isn't that almost just as bad?
Well, and that comes down to the architecture of the network. And so, obviously there is a concern that what if one of the nodes is malicious or even simply goes offline? That's where we are going to be building in layers of redundancy so that there will be multiple groups of nodes that are undertaking a calculation, and also multiple nodes holding the same particle, so that you have that redundancy where, if this particle is no longer available for this reason, there are other nodes on the network that also have that one so they can complete the picture.
Yeah. And it's interesting to note that there isn't, firstly, the nodes will be likely incentivized by staking rewards to do good. But there isn't actually an incentive for a node to do bad because they don't know what they're holding. So the request as it comes in to nodes that don't know each other, they literally have no idea what they are computing or figuring out. So to act maliciously would be a strange thing, especially when you don't have an idea of what you're actually doing.
Yeah. So there were a few things that got me really excited to talk about this with you guys. One was a non-consensus way of reaching agreement, which I think has some pretty big implications. But the other was the idea, you guys touched on it briefly, you called it information theoretic secure. I looked up the Wikipedia page, and the first line was like, it means that even with unlimited computing power, you cannot hack it. So what does that actually mean with regards to your guys' network and the way that you guys keep stuff safe?
So, okay. So you guys probably know encryption. You can visualize it maybe as a safe, right? You have a secret, you put it on a piece of paper, you put that paper in the safe, and then you close it and lock it. So that secret is protected by the hardness of a mathematical problem, which is how hard it is to break that code and open the safe. But by definition, there is one code that opens that safe. And so by definition, all encrypted messages are decryptable and are therefore, you can break them. So that's the problem with standard encryption. ITS is something different. The equivalent would be you take the piece of paper with the secret and you burn it down to ashes. So when I'm handing to you over one of these particles, I'm handing you over the ashes. And of course, it's not possible to go from the ashes back to the secret on the piece of paper, just like it's not possible for you guys to go from your particle to my secret. So it is unhackable in the sense that it does not rely on the hardness of any mathematical problem, like encryption does, like the factoring of prime numbers or something like that. You can even have infinite computational power and even future quantum computers, and you won't be able to hack it. The reason is that there is no information remaining in those ashes. There's no information that you can exploit as an attacker. And so that's the security level that Nillion works with, which is like kind of the best in class.
Yeah, I think we're really talking about a next generation in terms of security because of, as Miguel was pointing out, the information and being able to unlock encryption, and then the lack of quantum proof. Having unlimited computing power will allow you to break encryption, but with ITS, you're at a level of security where, like I said, you're reconstructing these particles, and mathematically it's not solvable unless you have all the particles together.
So you can see why, I was interested in this because there is a world that doesn't use encryption, yet cannot be hacked. It's like having a Fort Knox of the metaverse, if you like, right? The metaverse is coming, and our digital lives become as important as our physical lives, which is sort of one of the definitions of the metaverse. Then it's going to be important for us to have a extremely secure, literally a Fort Knox within that metaverse to store, not just our data, our passwords, our secrets, but metadata, that is used for either general purpose applications or things that we use to interrelate and to everything else. When I think about blockchain and how it started off as sort of you got money, NFTs, and where it's going, you have to have a world where there is a really secure area of decentralized processing, because otherwise, how are you going to get like large corporations? How are you going to? Right now, we have public blockchains. The contrarian narrative is a public blockchain made private, or a private public blockchain. That is actually where the world needs to go. Now, some of the blockchains do that, right? Like Zcash and a couple of others. But the bigger blockchains, the public ones, what I think Nillion represents as well is the ability to give private functionality to public blockchains, which is a really sort of contrarian narrative concept, which is exactly why I like it. Hedera Hashgraph, one of my first companies, was a non-blockchain way to achieve consensus. This isn't exactly consensus. It does have implications for consensus, but SMPC and consensus are kind of two different things, if that makes sense. So it's one of the reasons I was really excited about this is because of the implications of where the world's going to go. You're always in companies and in technology in general. To change the world, you kind of going to go to where the puck's going. It's just so obvious to me that, I hold NFTs in a wallet and I hold crypto in a wallet. And if one person finds out what that wallet is, there is software now that tracks, that tracks everything. I mean, there are hacks to things like MetaMask, to things like, to password repositories, and it's these sorts of problem sets that show me the kind of opportunity for Nillion.
There's actually a lot to unpack there. So, I mean, the obvious case seems like if what you're saying is true, it means that this is a disruption to encryption, right? Which means that not even talking about crypto things, the way that I would then store things that are important to me would change. So it sounds like that's the first thing, right, that you guys are probably going to go after, just how you store sensitive stuff, be it individuals or companies or whatever. The other thing, which I'd love to go into after that, is actually what you just talked on, Andrew, which is it sounds like because you have this network that doesn't use consensus to reach agreement, that uses a network in a different way, you can actually then plug that onto existing blockchains and then make them private, give a public blockchain that private functionality, which I think that's where my brain just starts to kind of melt. So
to your first point, we're not talking about just the disruption of encryption. That is a big part of it, but we're also talking about a fundamental shift in the way that sensitive information is used in the world, or how information is used in the world in general, by being able to take a piece of information, store it in this incredibly secure way with encryptionless encryption, but then to be able to run computations to process that information fundamentally changes the way that we use sensitive information. In the world right now, in order to utilize any piece of sensitive information, it has to be in a centralized form, right? If it's encrypted, you basically put it inside of a safe, but then you need to unlock that safe, you get the centralized information, and then you use it for the thing you want to do or the computation you want to do. With this, we can actually use that sensitive data or any piece of data in its decentralized form without having to recreate it to do something. And that's a huge shift in the way that sensitive information is used. It's not something that's done right now.
And to bring it to actual use, right? So imagine, just for a second, Ethereum was a world computer. Imagine, for example, that this could empower, and the underlying technology can do much, much more than this, but it can power a world safe, right? A decentralized, free, potentially free because of the token economic system, world safe, where you literally have a public utility for the storage of secrets. You can determine how many nodes, you can determine if you keep one of the shreds, but it's a weird concept, storing the things which are most important to you, whether they be passwords, documents, wills, company databases, et cetera, on this decentralized network of nodes. I mean, right now, I bet everyone here stores. I'd be surprised if there was someone who stored something in a non-centralized way. And yet, we trust cryptocurrencies to process transactions, the storage of value in a completely decentralized way. It doesn't make any sense. You're still having data centralized and even data centralized and transactions decentralized. Even the storage and processing of data within, say, Ethereum, again, you would have to, you duplicate that data amongst nodes. I mean, look, Ethereum and the blockchains, we're not attacking them, we want to supercharge them. They were designed not for the storage of data. The consensus nodes do inherently a different thing, This is why I said it takes a slightly different paradigm shift. Sorry, don't want to.
It seems like you guys are trying to do to information what Bitcoin did to money, where you're trying to take information and then decentralize it in a way that I guess is more owned by the people. Would that be safe to say?
Yeah.
I was just going to chime in here with the sort of real world example. And it was the light bulb moment for me when Miguel was explaining this to me, because the maths was sort of abstract and I was going, don't get this. But when he explained it in a real world example, and the real world example he used was a credit card. What if you take your credit card and you put a mask over the front and a mask over the back, and you couldn't see any of the numbers, and then you cut a scissors and you cut it up into 100 pieces, and you gave each piece to a different person who's running a server. I'm doing this in digital form. So you now have something. You don't know what it is because it's just blank on the front and blank on the back. but it means something to me. So I can still process a payment by utilizing all of those 100 nodes to process my decentralized credit card as if it was all whole on a single central server. Except none of the guys who hold these bits know what they're actually holding. It's completely oblivious to them. Think about the scale of that for any piece of sensitive information. It's not just credit cards or private keys or anything around an NFT. It's anything that potentially you want to distribute or store in a very safe way.
Yeah, so those are the, I guess, in a non-crypto world, that's how you would use it. The stuff that got me kind of really interested was, let's go back to the part where you talked about you'd be able to make a public blockchain private. It's kind of an interesting concept, right? And so, from my understanding, you would take something like the Nillion network and you would connect it to, say, Ethereum or Solana or whoever, and they would be able to route their either contracts or transactions to Nillion. So how would that work? So Ethereum, you'd have a Nillion smart contract on Ethereum.
Yep.
And then that contract would then pull information into the Nillion network.
Yeah.
At which point you guys would compute it in a private way and then send the result back.
So,
Is that the vision?
so firstly, this is, just to be clear, this is still, theoretically, this will work, right? It's still an engineering feat. Interoperability in general is not a mathematical feat, it's an engineering one. The way the Nillion network works is a mathematical feat. But you could either compute the smart contract within something like Ethereum and then put the output stored within Nillion, or theoretically you could have an Oracle bridge or some sort of other bridge into the Nillion network such that the compute could occur on Nillion and then the output could be given back to the requesting smart contract on Ethereum. And Ethereum is, I should be saying Hedera Hashgraph because that's the one I created. So the first thing is the potential privacy of smart contracts. The second is transactions, right? So what you could do is have, let's say, me going to all of you people, all of you nodes, and saying, hey, I want to send this transaction. So then you construct a signed transaction, which you don't know what you're constructing. Then we send it to Ethereum, and that executes the transaction on Ethereum. There is also the possibility that you have a sort of tumbler system. Now, I wouldn't want to create a tumbler. I don't like the feeling of tumblers because they encourage money laundering, terrorism, et cetera, et cetera. What a tumbler is basically you can send a transaction into a network, which then mixes it with other transactions and then shoots a transaction out. So you don't know where the money is coming from. Now, eventually you can match the exact types of if you're sending a transaction of 2.7769 ETH, then you'll be able to track it at some point in time, unless it's sent in little pieces. It's basically very, very hard, right, to do. But we could probably do that because we could verify biometrics or KYC, etc., in a way that doesn't empower criminals, but does still provide that sort of transaction hiding. So these are all things that the network could do given the right engineering. And like I said,
basically you're taking any information and then you are breaking it into particles and then computing off of it. Which in this case you're not really tumbling it. You can't recognize what's being calculated because it's quote unquote particleized. Is that the idea?
Yeah.
Yeah, it's not an exercise of trying to distract the attention, which is what tumbling is about, which is just I mix my transaction between or amongst many other transactions to try to hide it somewhere. This is something different. You cannot get from the particle to the information. So it's a completely different method to hiding information. And as we've been describing, it's completely sound. It's information theoretically secure.
But so it sounds like, so is this able to connect in theory to any consensus-based blockchain and then to be able to run computations for it?
Yes, in theory you can offload the computations to Nillion so that they can run in a privacy-preserving way. You don't see what's going on inside. The nodes cannot have access to that. And then you can connect back to existing blockchains. We are like an infrastructure, a new type of infrastructure that can link to existing blockchains, can spawn or create new blockchains as well, and can service them in a number of ways.
So this is when the DeFi degen in me starts to like light up, and my brain goes, okay, well, if you can connect to every blockchain and you're able to run computations and you do it in a non-consensus way, then doesn't that solve for being able to either create multiple wallets or being able to move money around between different blockchains? Don't we start to get into the land of, you're starting to connect existing blockchains in a way that a consensus blockchain wouldn't be able to? Is that kind of where you guys see this work expanding into?
It's potentially a place where that can go. So interoperability is currently there are one or two projects attacking interoperability using multi-party computation. But they just don't use our flavor, our technology, our kind of evolution of it. I don't even know if I would have to look into them a little deeper, but don't even know if they encrypt they transform and then store the nodes, store the information as we would. But yes, theoretically speaking, there is nothing to say that you couldn't take information from one blockchain, compute it, or privatize it within the Nillion nodes, and then send it out in a different format. By the way, I know there are questions in the room. We will. I promise we will take them. People are putting their hands up. So
on that as well, with multiple chains and being able to interact with multiple chains, we can construct wallets where we could have a singular access point, so several authentication methods to access them, but then those private keys would be held in this decentralized transform way and able to sign transactions across blockchains. So you could have a wallet that had every blockchain inside of it, the private key for that blockchain then stored in a way where it's unhackable and can sign it using the decentralized method, but interact between all of the different blockchains.
Well, you would never have to reconstruct the private key. You would just construct a signed transaction.
Yeah. You could construct a signed transaction, but you'd be able to have essentially one access point to a wallet for every blockchain in existence.
Yeah, because right now, on my MetaMask, to use MetaMask on my computer, I have to put my private key into the interface. And so it's sitting on my computer. So you're saying, in this case, my private key would be on Nillion. Nillion would sign on my behalf in particle form so that I'd never have to touch my private key.
And we could add authentication methods on top of it that would be much more secure than MetaMask, where essentially you put in your password twice and you can see your private keys, right? We could, with this network and the speed of it, and also with the decentralization, we could use something like biometrics, we could use voice recognition, we could use passwords, and there are so many different layers of authentication to make sure that the person that is accessing it is the right person, instead of MetaMask, where it's, you have your password, you input it twice, you can see your private key.
I mean, that was kind of the holy shit moment for me, right? Where it was like, wait, so I can have, my private key, I don't even have to touch it. And technically you guys are able to sign off of it. I think does that cover kind of all the different layers of the rabbit hole? From encryption all the way down to being able to solve potentially parts of interoperability. Is that kind of the scope of what you guys are going after from top to bottom?
Sorry, could you just rephrase the question?
Sure. So you guys started with encryption,
Yeah.
which is I can keep your stuff safe,
Yeah.
in a way that no one can hack.
Yeah.
All the way down to the bottom layer, which is I can connect to blockchains and basically make it so that they can communicate with each other or run private transactions.
Yeah.
Is that kind of the entire world that you guys are going after?
I mean, it's, I would say yes, but to understand what it is, it's a different way for several computers which are not related to each other, which may be nefarious actors, to communicate and to come to communicate and work together. Whether that be to assist consensus use cases or some other wave function. So yes, we've got encryption. Yes, we've got the hiding of metadata. Yes, we've got private transactions. Yes, we've got the storage of biometrics. Yes, we've got the storage of biometrics where you're not actually storing biometrics. Yes, we've got this sort of metaverse layer of privacy. Yes, right now with, for example, with NFTs, I don't know if you guys have ever minted an NFT, but if you can see the metadata, you can kind of get the legendary NFTs. It's happened to me several times where I've been the one on the receiving end, so I haven't been able to manipulate that. But there are other people getting the rare NFTs where I'm trying to mint them. And these are serious problems. They're problems which are inherent within public blockchains. This is a problem with public blockchains, right? They're great for transparency, but they're really crappy for specific other use cases. So maybe it is in, for example, another use case would be, for example, a way to provide anonymous KYC, right? Like, that is yet another thing that could come out of this. What I'm saying is that we're still exploring. It's like Ethereum, right? What can you do with Ethereum? We're still discovering that. I mean, there's lending platforms, there's decentralized exchanges, there's NFTs. We're still discovering. There will be probably supply chain. There will probably be, I don't know. There's like people inventing all sorts of synthetics, all sorts of crazy weird stuff, right? So, what I'm saying is that the base layer of technology, because we have literally a different way that a decentralized system can communicate, you have several, use cases coming off of which are very exciting.
That's what's really interesting about this technology is that we actually don't know what all the use cases are yet. And over the last several months, it has been, we started out with some ideas in mind and around real-world use cases for disrupting sensitive information, and you mentioned KYC, biometrics, et cetera. But then we start finding these different layers where we're basically peeling back this onion and realizing that there are even more use cases underneath it. And part of the idea with what we're creating with Nillion is enabling entrepreneurs and developers to come on and develop their own use cases as well, because there's some smart people involved with this project, but at the end of the day, there's a whole world out there of developers who have, are incredible at what they do and can find use cases that we aren't even recognizing right now. And
the funny thing is, so firstly, congratulations for coming here. This is the first time we've actually spoken publicly about this at all, and we kind of did want to make it sort of just a smaller audience, and love to hear your questions later. But it is just a different way to see things, and so that's why I was sort of excited from it.
This is fascinating stuff. I'm really curious to see where this goes. If these guys want to find out more about the project, where can they do that?
Just give them your email.
Yeah, you can always shoot me an email. It's alex@nillion.com. So ALEX @Nillion NILLION.com.
And the word, it's funny, the word Nillion actually means a whole lot of nothing. And so what is on the network is literally a whole lot of nothing, and that's why we chose it.
Take a piece of information, transform it, break it into particles, send it off to all the nodes. That information is now stored nowhere because it isn't actually anywhere until you.
And it's not actually the information, so
So it's so Nillion is a whole lot of nothing.
Yeah, but we'd love to hear from you guys. We'll stick around to answer questions, but just want to be respectful of everyone's time. Thanks for coming out.
All right, thanks guys, appreciate it.